Hi boys and girls, it's Mr. Wassman, and today we are going to find many different names for numbers. We are in our home links, Unit 8, Lesson 13. Let's read the instructions. It says, write 5 names in each box below. Use as many different kinds of numbers, such as whole numbers, fractions, decimals, and different operations, addition, subtraction, multiplication, division, as you can. So let's take a look at the first number, 9,990. Well, one way we can take a number and rename it is to break it down into its extended form. 9,990 is the sum of 9,000 plus 900 plus 90. That's one way to think about that number. It's a number that has 9 thousands, 9 hundreds, and 9 tens. Another way to think about that number is that it has a 0 at the end, which means it is a multiple of 10. So another way to think about this number is to think about it in terms of a multiplication problem. 9,990 is the product of 999 times 10. Now these are just 2 different ways that I can get to this number. Okay, when we create these naming boxes, it's a way for students to demonstrate their creativity. Okay, and a lot of times kids will approach problems in different ways. So you might look at this number 9,990 and think, oh, this is the difference in a subtraction problem. Okay, for example, 10,000 is just 10 less, or 10 more, I should say, than 9,990, because if you add 10 to 90, that makes it 100, which adds another 100 to the 100's place value, which puts another 1,000 in the place value, which tips it over to the 10,000. So 9,990 is the difference, or the answer to a subtraction problem. Okay, let's take a look at number 2. Okay, we have a number here that is in decimal form, 32.68, or 32 and 68 thousandths. Now again, you can approach this by taking it apart by place value. 32 and 68 hundredths is the sum of 30 plus 2 plus 6 tenths plus 8 hundredths. Okay, so you can break that apart by separating all the place values. But I thought it might be interesting to challenge you by coming up with a way to represent this using multiplication and division. Dealing with decimals is sometimes a little daunting. So what I like to do is I like to take that number and ignore the decimal for just a moment and just deal with the digits. For example, 32 and 68 hundredths is an even number, so that means it's divisible by 2. Now if I take just for a moment the decimal point, I'm just going to ignore it for just a moment. I'm going to divide this whole number by 2. Now 2 goes into 3 one time, because 1 times 2 is 2. Subtract the difference, bring down the 2, compare and check to see that 12 is bigger than my divisor, so I'm going to repeat. I'm going to repeat like 3 more times. 12 is divisible by 2 because it's 6 times as big, because 6 times 2 is 12. I bring down the 6, and then I repeat again. And as you can see, I'm going to have an even quotient with no remainder. Okay, so if I divide 3,268 by 2, I would get an answer of 1,634. But since we're dealing with a decimal point here, 32 and 68 hundredths is divisible by 2 because I get a quotient of 16 and 34 hundredths. Now, because I was able to divide this number by 2, I can then represent 32 and 68 hundredths as the product of a multiplication problem. 16 34ths times 2. Okay? Again, these name boxes or name collection boxes are just ways for students to show their creativity. Another way you could show your creativity is simply make 32 and 68 hundredths the answer to a subtraction problem. For example, 33 is a whole number. What would I subtract from 33 to get an answer or a difference of 32 and 68 hundredths? Okay. Well, I could figure that out by subtracting 32.68 from 33 because it's going to be all part of a fact family triangle. So if one of my addends is 32 and 68 hundredths, and my sum is 33, my missing number is going to be my other addend. So I'm going to find out what it is by subtracting. So if I start with the 0 hundredths, I can't take away 8, so I got to look at the tenths to borrow. Nope, I don't have enough there. So I'm going to go all the way to the ones, place value, and make 3 ones into 2 ones. I'm going to transform no tenths into 10 tenths, and then borrow one of those tenths to make my no hundredths into 10 hundredths. And now I subtract. And I find that the difference between 33 and 32 and 68 hundredths is just a measly 32 hundredths, which now tells me what would I subtract from 33 to get a difference of 32 and 68 hundredths. I would subtract 0.34. That would be my missing number in this fact family, 0.34. Okay? So we have a couple name boxes that are missing a number, so you would have to come up with your own and then fill in some viable options for renaming the number that you chose. Okay? Again, a way to demonstrate your creativity. Finally, down at the bottom we have some subtraction problems that involve mixed numbers, and all of them are going to require you to do some regrouping. So let's just take a look at number 5, shall we? 5 1/4 minus 1 3/4. Now again, when I have multiple place values, I am going to set up my problem vertically. 5 1/4 minus 1 3/4. And you see, when I line that up vertically, I can see right away that I have a 1 in the numerator on top and a 3 in the numerator on bottom. And it's not enough to subtract. Okay, so I have to do some regrouping. So when I regroup from a whole number to a fractional place value, I have to think in terms of how many parts does each whole number have. Okay, if I'm dealing in fourths, when I take away one of my whole numbers, like so, making 5 into 4, I'm going to take my 1 whole and make it into 4 fourths. Okay? So I'm going to add my 4 fourths to my 1 fourth, making my fractional place value now be 5 fourths. Like so. Now I just subtract my 3 fourths, or the 3 in the numerator, from my 5 in the numerator of 5 fourths. And of course 5 minus 3 is going to give me 2 fourths. Then I subtract 4 minus 1, and then I'm left with 3 and 2 fourths. That's my answer. Now another way you can approach this problem is to convert those fractions into decimals. Okay, 5 1/4 would be represented as 5 25 hundredths. A fourth of a dollar is 25 cents, right? And then 3/4 would be 75 hundredths. If I convert my fractions into decimals, then the number values are easier to interpret. Okay, so again, if I subtract 5 minus 5, I'm left with 0. If I try to subtract 7 from 2, I can't do it. So again, I have to borrow a whole number, but this time I'm just going to take my 2 tenths and make it into 12 tenths. 12 minus 7 is 5, and then 4 minus 1 is 3. And 3 2/4 is then transformed into its decimal equivalent, which is 350. And with that, we come to the end of our video tutorial. I'm confident that you will be able to complete the rest of these problems on your own without too much trouble. Hey, did you know that Lesson 13 is the last lesson of Unit 8? And as you probably know by now, Unit 8 is the final unit in our 4th grade Everyday Math series, which means, congratulations, you made it to the end. You are now well on your way to 5th grade. I hope that this video, as well as all the other videos that I've posted over the last year or so, have been helpful in that process, helping you along your journey to get you ready for 5th grade and beyond. I hope that you have a wonderful summer, and good luck with next year. Have a good day. Thanks.